Hello, pre-algebra. Mr. Lawrence here with your flipped lesson for February 10th. This is for the weekend. It shouldn't be too hard a lesson. It should be review from last year. We have to cover it before we can move on, just to make sure we don't have any holes in our learning. We're going to be talking about area. Oh no, I'm not in right mode. Does that mean I'm in wrong mode or left mode? I'm not sure. Area and perimeter. And today, we'll keep it simple, and we're only going to talk about squares, rectangles, and triangles. All right. Now, first of all, I know that in 7th grade they give you 8 different formulas or blah, blah, blah. I mean, whatever. Mr. Lawrence and Mr. Underhill have decided that in your best interest, we were going to make this as simple as possible. We will give you a formula sheet that they will give you on the OA. It'll be the same exact formula sheet. We'll make a copy of it. It's wonderful. But that formula sheet, I don't understand a lot of things they do on there. But you can get it and you can use it. We are going to teach you one formula and then use it for many different shapes. And then you'll be able to just adjust it based on the shape. And you'll see what I mean by adjusting it. So my favorite area formula is not a triangle. My favorite area formula, okay, is base times height. Okay, and I use base times height all the time. That's really all I use when I'm dealing with polygons, especially quadrilaterals and triangles. Now, other shapes, it gets a little more confusing than that. Okay, but base times height is the basic way to go. Now, there's one problem. Some of you mistakenly think that base is the side the shape is sitting on. Okay, well, in this case, with this triangle, you would call this the base, right? Okay, but what if I turn the triangle that way? Well, that can't be the base anymore. And then you say, well, this is the base. Well, but then it's not sitting on it. So don't ever use the argument that the base is the side it's sitting on. Okay, it doesn't make sense when you get into further mathematics. What you do need to know, and you might want to stand up for this, stand up nice and tall. I'll draw a picture of you standing up nice and tall. Okay, and I'll draw the floor. Okay, so there's you and there's the floor. My, you're looking very lovely today, I must say. All right, so notice that this would be the measurement of your height, wouldn't it? Okay, and this is the floor here, the blue line. What is your height doing with the floor? Now, look, don't tell me you're standing on the floor. I know that. Okay, look at what your height. The height is the measure from the top of your head to the bottom of your feet. What is it doing with the floor? It's making something. Can you see it? It's making a right angle. Base and height always make a right angle. They make a right angle. In fact, you could say they are perpendicular. Perpendicular means two lines or two segments that come together at a 90-degree angle. So they make a right angle. They're perpendicular to each other. That is the key to doing area. Okay? Perimeter is just the distance around a polygon. That's all it is. The distance around a polygon, which basically means you add up all the sides. So let's do a real simple one. Let's take this rectangle here, and I'm going to give you the right angle here, and I'm going to tell you that this is 5 centimeters tall, and it's 10 centimeters, excuse me, got the hiccups, long. First, let's do the perimeter. All right, the perimeter. Now, before you try to tell me it's 15 centimeters long, please remember the perimeter is the distance around the entire polygon. You have to walk around the polygon. So let's take a walk. How far have we walked? 10 plus 5 is 15, plus another 10 is 25, plus another 5 is 30. So the perimeter of this is 10 plus 5 plus 10 plus 5, which is 30 centimeters. All right, 30 centimeters is the distance around the polygon. All right, area, area. First thing I need to do is identify B and H. How am I going to do that? I'm going to find my right angle. Oh, look, I found my right angle. It doesn't matter whether you call the 10 the base or the 5 the base. It doesn't matter. It looks more like the 5 would be the height because it's going up, but it does not matter. So 10 centimeters times 5 centimeters. All right, now 10 times 5 is 50. Now, your units here, this is a little tricky. You have 10 times 5, but you also have centimeters times centimeters. It can't equal centimeters. Here's why. Does 3 times 3 equal 3? Of course not. Thank you for playing. Does 5 times 5 equal 5? No way. No way. Now, I know some of you are saying, well, Mr. Lawrence, I know 3 times 3 is 9. And I don't disagree with you. But couldn't you also say it is 3 squared? Right? And 5 times 5, you could say as 5 squared. Right? You guys know that. 10 times 10 could be 10 squared. So if 3 times 3 is 3 squared, 5 times 5 is 5 squared, 10 times 10 is 10 squared, what is Buckeye times Buckeye? Buckeye squared. Buckeye squared, not Buckeye. Buckeye squared. Follow the pattern. 3 times 3, 3 squared. 3 times 5, or 5 times 5, 5 squared. Well, centimeters times centimeters, centimeters squared. Or you could write it this square centimeters. Either way would be correct. You don't need both, but either way. So there's the area of that rectangle. All right, let's check out some triangles here. And this triangle will be relatively simple. Okay, and I'm going to tell you that this is 15 inches. Excuse me. This is going to be 12 inches. And that's all I'm going to tell you. All right, do you think you can do the perimeter? No, I don't think you can, because you don't know how long that side is. You have to figure out that side. So I'm going to use my old friend, the Pythagorean theorem, because I know he can help me figure out the missing side of a right triangle. Find C. And I'm going to plug in x and 12. I'll get x squared plus 144 will equal 225. Oh, subtract 144 from each side. X squared is going to end up equaling 81. X will equal 9. How did I do that? I took the square root of each side. All right, so x is 9. Okay, so now I can do my perimeter. 9 plus 12 is 21. That's 21 plus the 15. Looks like it's 36 inches. All right. Area. Area. I'm going to use base times height again. But isn't a triangle half of a rectangle or half a square, right? Or half a quadrilateral? So if I multiply base times height, I'd be finding the area of a square or a rectangle. See, I'd be finding the area of this whole thing when I only want the area of this. This is all I want here. I don't want the whole area. I want half of it, right? So to get half of it, I'm going to cut my answer in half. I'm going to divide by 2. Now your formula sheets might go 1/2 the base times the height. It's the same thing. It's the same thing. They mean the same thing. I don't care which form you use, as long as you're getting it right. So I'm going to go 9 times 12. I'm going to divide by 2. All right. You can do this one of two ways. You can go 9 times 12 and then cut it in half. Most of you will be most comfortable doing that. And I think that's going to be 108. And then when you divide by 2, you're going to get 54. Now I'm going to do it this way. 2 goes into 12 6 times. 9 times 6 is 54. And I will be in inches squared. All right, I think that's enough for today. Monday, we'll get some practice with this kind of stuff. Mr. Lawrence, signing off. Have a good weekend, everybody.